Hi, everybody. Today starts section 4.3, day 4, which is a real-world standard form inequalities practice day. And if you think about it, it's really your second practice day because the set of questions we worked on last was a group of 4 for you to try on your own. It was the pretzel chip question. There's a football one on jeans, pairs of jeans and shoes, and oranges and apples, I think, was the last one. You know what I'm referencing. It's what you worked on yesterday. So today's practice is really bringing all of the real world we've done so far with inequalities into one place for you to try one more time on your own before tomorrow's quiz. These first 3 questions just ask you for the setup. The directions say here for numbers 1 through 3, define the variables and write a linear inequality in 2 variables to represent each problem situation. So let's work on the first one. Tanya is baking zucchini muffins and pumpkin muffins for a school event. She needs at least 500 muffins for the event. So I see here the 2 things being discussed are the zucchini muffins and the pumpkin muffins. So we'll let X equal the number of zucchini muffins and Y will equal the number of pumpkin muffins. And the only other piece of information we have is that she needs at least 500 of them total. So I'm hoping that this rings a bell with way back in Unit 3 when we set up an equation that was number plus number equals total number. It's the same idea, but now we're going to apply our information with the inequality to it. So the number of zucchini muffins, which is represented by X, plus the number of pumpkin muffins represented by Y, has to be at least, so greater than or equal to the 500 total that she needs to make. So again, that same quality of number plus number and then a total. Number 2 says, Hero needs to buy new pens and pencils for school. Pencils cost $1 each and pens cost $2.50 each. He has $10 to spend. So I see reference to pens and pencils, and he doesn't know how many he wants to buy. So X will be the number of pens. Y is the number of pencils. And it may be very tempting to now say 1X. I actually wrote that the first time, and then I had to catch myself because it says pencils cost $1. Pencils is Y. Pens cost $2.50 each. So it's going to be 2.5 or 2.50X, because pens are $2.50 each, tells me right there, plus 1Y. This 1 is optional. You could just write plus Y. He has $10 to spend. So think about what that means. He only has a $10 bill in his pocket. He cannot spend any more than that. So less than or equal to 10, up to the $10. Number 3 says the Foxes are playing the Titans. The Titans have been scoring 28 or more points per game this season. Between 7-point touchdowns and 3-point field goals, the Foxes need to score more than the Titans' lowest score to have hope of winning the game. So we've got touchdowns and we've got the field goals. I know how many points you get for the touchdowns. I just don't know how many they need to score. So X will be number of touchdowns. And Y will be number of the field goals they score. Seven points per touchdown plus 3 points per field goal. And I know that they want to score more than the Titans. So when I reread this information, I know the Titans have been scoring 28 or more points. So they have to score at least more than 28. Notice I didn't put or equal to, because if the Titans score 28 and then the Foxes score 28, they tie. So at a minimum, the Foxes have to score at least 28 points. So to recap, a value times X plus a value times Y greater than or less than or equal to something, some inequality depending on the question, and the total goes right there. To get ready for the next set of practice questions, List the 4 steps to solving a real-world linear inequality by graphing. So first, we are going to underline the question. Underlining the question helps us to pay attention to what is actually being asked. Reading the full question. We underline it, we'll pay attention to it. Step 2, define variables. And write the inequality. After we have our variables and inequality, think about what comes next. How do I figure out how to graph these real-world inequalities? Our method, our strategy has been to calculate the x and y intercepts. And graph them. So once you find them, put them on the graph. Once I have my intercepts, I can create my line, but now we need to figure out how to shade. Think, how do we know how to shade? Again, we've had a pretty solid, consistent strategy of checking. So check 0, 0 to know which side to shade. Remember, the only time you can't use 0, 0 is if your line actually goes through 0, 0, which doesn't happen often, but it does happen. So 99% of the time we'll be able to use 0, 0. Sometimes we may have to choose another point. We have warmed up our writing skills with 1 through 3, and we've just outlined our 4 steps of the strategy. So let's use it. Let's get into number 5. Notice in giant bolded letters, it says, for each real-world situation, remember to first define your variables and write your linear inequality. So we're going to follow that advice, starting with number 5. Leah has $5 to buy notebooks and pens. Notebooks cost $1.25 each, and pens cost 75 cents each. Write and graph an inequality that models the possible ways Leah could spend her $5. It doesn't use language like how many of this and how many of this in the question, but look at what we're talking about. We're talking about how many ways she can spend her money. And when I reread my question, I see that she's buying notebooks and pens. So we're going to let X be the number of notebooks she buys, or she can buy, number of notebooks, and then Y will be the number of pens. Now that I've defined my variables, we can write our inequality. How much does a notebook cost? Go ahead and reread for that information. How much does a notebook cost? When I read, it says notebooks cost $1.25. So that will be 125x, $1.25 per notebook, plus pens cost 75 cents, so plus 0.75y. She can spend up to this $5. That's all she's got, so less than or equal to 5. We have accomplished the reminder in bold to make sure we defined our variables and we wrote our inequality. We're now ready to get going on graphing. To graph, we're going to find our intercepts. From day 1, I have asked that you write these little titles, so if this is the first time you're doing it, that's great. It'll help you on tomorrow's quiz. X-intercept, let Y equal 0. What's nice about that, 1, it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters and or numbers. Not hard to write. But what's great about it is an amazing set of directions. To find the x-intercept, let y equal 0. So let's do that. 1.25x plus 0.75 times 0 equals 5. When we are finding intercepts, we are momentarily going to treat this like an equation because we're actually solving for a single value. figuring this out, anything times 0 is 0, so this becomes 1.25x equals 5. We'll divide both sides by 1.25. If you have not gotten a calculator yet, please press pause. Go grab your calculator so that you can do this math with me if this one is one you struggled with. Five divided by 1.25, I got x equals 4. Put it in a box so it stands out. We just found our x-intercept. X equals 4. To find the y-intercept, let x equal 0. So this becomes 1.25 times 0 plus 0.75 y equal to 5, equals 5. Anything times 0 is 0. We have 0.75y equals 5. We'll divide both sides by 0.75. In your calculators, 5 divided by 0.75, what did you get? I got a decimal. And when I rounded to 2 decimal places, I got y equals 6.67, which for graphing purposes, I'm just going to say y equals 6.7. To graph that, here's 6 on the y-axis, here's 7. It's going to be close to 7, but not at 7. We now have 2 points. It's exactly what we need to graph a line. So use a straight edge, use your ID or a piece of paper folded into 4s, whatever works, as long as it's nice and neat and it comes out to be a straight line. Arrows on each end. We've successfully found our intercepts, we've graphed our line, and last but not least, we need to figure out what side to shade. To do that, we are going to check 0, 0. My line does not go through 0, 0, so I can actually do that check. This will be 1.25 times 0 plus 0.75 times 0 less than or equal to 5. So notice, when we move back into the check, we're back to having an inequality sign because I'm ultimately looking for a true or false statement. This is 0, this is 0, 0 less than or equal to 5, true or false? Is 0 less than or equal to 5? Yes, it is. True. So here's 0, 0. If 0, 0 is true, any ordered pair on this side is true. So we're going to shade this side. Keep it neat. Please don't squiggle. Let's just use some nice straight lines like that. But we're going to keep in mind that we are dealing with a real world scenario. So in the math world, this is the correct solution. But in the real world, notice the x-axis here represents number of notebooks. We cannot have negative notebooks. The y-axis represents number of pens. I cannot have negative pens. So please take a highlighter and highlight only where both notebooks and pens are positive, which is this triangle right here. List 2 possible solutions and explain their meaning. I would recommend, if you're allowed to pick any ordered pair you want, choose something in the middle. If you choose anything on the edge, think back to today's discussion. Anything that comes up on the edge, like if I asked you if she buys 2 notebooks, how many pens can she buy? Depending on your line, 3 looks possible. But that's on the edge, and we have to be careful because shift this line just a little to the left, a little to the right, it could be or not be possible. So if you chose a point on the edge, you have to check it by plugging it in. So for me, if I get to pick anything I want, I would choose like 1, 1, because that's a for sure. She can buy 1 notebook and 1 pen. Let's say I did say 2, 3. Because there's nothing wrong with saying that. It's just an edge point, so to speak. So I would recommend if you're going to say 2, 3, or if a question asked you, like I had just said, if she buys 2 notebooks, what's the most number of pens she can buy? I would expect to see 2, 3 with a question mark, and then let's plug it in. So that would be 1.25 times 2 plus 0.75 times 3, and we want to see if this comes out true or false, if it's less than or equal to 5. Go ahead and pause. Use your calculators, please, to check this point. $1.25 times 2 is 2.5 plus 0.75 times 3 is 2.25. Again, trying to see if it's less than or equal to 5. $2.5 plus 2.25 is 475. Ask yourself, is 475 less than 5? Yes, it is. So she can buy 2 notebooks and 3 pens. If this had been an at most question, if she buys 2 notebooks, how many pens can she buy? You would have just proven that she can buy at most 3 pens. Number 6. Leon has $10 to buy squash and carrots. Squash costs $1.50 each, and carrots cost $2.75 per bunch. Write and graph, let's underline the question, write and graph an inequality that models the possible ways Leon could spend his $10. Reason, what is he spending his $10 on? He's buying squash and carrots. So X will be number of squash. I put that first just because it came up first. And then Y will be the number of bunches of carrots. If you wanted to shorten that to number of carrots, I would be okay with that. But technically, these come in bunches. Still need to write our inequality, but now that we know what our variables represent, we can actually go ahead and do that. So I know squash costs $1.50 each, but I don't know how many he can buy. So $1.50 per squash. I'm actually going to choose to write it over here for space reasons. $1.50 per squash plus $2.75 per bunch of carrots. And he's only got a $10 bill in his pocket, so this is going to be less than or equal to 10. Now that I have my inequality, we can use it. We can go find our intercepts. Again, the title, little title helps. X-intercept, let y equal 0. We're going to do just that. So this will be 1.50x plus 2.75 times 0 equals 10. Remember, when we're finding intercepts, it switches to an equal sign because we're finding an exact value. This is 0. We get 1.50x equals 10. We will divide both sides by 1.50 or 1.5, same thing. What do you get? Let's see, 10 divided by 1.5. I got 6.6 0.67, which I will say is 6.7 for the sake of graphing. Y-intercept, let x equal 0. Go ahead and pause the video here if you haven't done this part on your own. Find the y-intercept and we'll compare answers. So I'm going to write 1.5, 0 times 0 plus 2.75y equals 10. This is gone, equals 0. So that leaves me with 2.75y equals 10. I'll divide both sides by 2.75. 10 divided by 2.75 equals 3.64 when I round to 2 decimal places. So for the sake of graphing, I will round it to 3.6. If this had been 5 or higher, I would have said 3.7. We have successfully found our intercepts. Let's go graph them. So x equals 6.7. Here's 6. Here's 7. 6.7 is closer to 7, but not 7. My y-intercept is 3.6. Here's 3. Here's 4. 3.6 is a little past halfway. And then we'll take our straight edge and graph. So take your ID or a piece of paper folded into 4s. Anything you have that's a straight edge, a ruler would be nice, but if not, we can always make one. Take a piece of scrap paper, fold it into 4s, and you have a ruler for free. All right, we have our line, but we still need to figure out which side to shade. To do that, we will check 0, 0. That will look like 1.50 times 0 plus 2.75 times 0. Don't drop the decimal place like for me. I'm going to go back and make that bigger so it stands out. Less than or equal to 10. Gone, gone. Both equal 0. So 0 less than or equal to 10. True. So I know that I will shade this side, the side that 0, 0 is on. But again, I can't have negative squash, right? X represents the squash. I can't have negative squash. I can't have negative carrots. So the real world answer here is just, oops, too big, just this part. So take your highlighter, make this section stand out to you. You're asked to list 2 possible solutions. Again, if you are allowed to choose whatever you want, I would recommend sticking to the middle. Anything that's clearly in the middle is perfectly acceptable without a check. So for example, 1, 2 means can buy 1 squash and 2 bunches of carrots. I can't fit bunches of carrots, but you do that, 2 bunches of carrots. If you chose something on the edge or were asked something like if he chose to buy 1 squash, what's the most number of carrots, bunches of carrots? Well, 1, 3 looks like it would work, but anything on the edge requires a check. So if you chose to say 1, 3, that's fine, but because it's on the edge, I would expect to see a question mark and then do the check. We practiced that a lot in class today, so I'll leave that to you. If you have a question on that, let me know. But again, moral of the story here, if a point is on the edge, check it. Plug it back in, make sure it's still a true statement. Number 7, Olivia makes and sells muffins and scones at a school bake sale. She sells muffins for 50 cents each and scones for 80 cents each. She hopes to raise at least $20. Write and graph, underline, write and graph an inequality that models the possible ways Olivia could reach her goal. I've underlined my question, time to define the variables. Well, to reach her goal, she's selling 2 items, muffins and scones. I know the cost of each, but I don't know how many she's going to sell. So we're going to let X be the number of muffins, and Y will be the number of scones. We've underlined our question, we've defined our variables, we're ready to write our inequality. So muffins sell for 50 cents each, and that's what X represents. So 0.5X. By the way, that's the same as 0.50X. So whichever you prefer. 0.5X plus 80 cents for the scone, so 0.8Y. She wants to sell at least $20. That is greater than or equal to 20. So at least 20. And now I have my inequality. Now that I have my inequality, we can graph. Let's do that by finding intercepts. I'm actually going to pause the video here, do my work, and then when you're ready, we'll compare. So when you pause it here, the next time you press play, the whole solution is going to come up for what the intercepts are, okay? So go ahead and pause, and I'm going to pause, and then we'll compare answers. So here's what I got for my intercepts. If we match, fantastic, we're ready to graph together. If we don't match, press pause again and follow my work, compare your work, and see where we may have differed a little bit. We're ready to graph. Now, my very first thought is, wow, this is 40, and that's a 32. How could 40 possibly be on this graph? But then when I look, what is this actually counting by? We're not counting by ones because 1, 2, 3, 4. This is definitely not a 4. How about twos? 2, 4, 6, 8. Nope. How about fours? 4, 8, 12, 16. So we're counting by fours. That's very helpful to us because if this is 32, then this is 36, and this is 40. So 40 is on the graph. Great example of not always assuming that the graph is counting by ones. Same thing here, 4, 8, 12, 16. The y-axis is also counting by fours. So here's 16, here's 20, here's 24. So 25 is just a little bit above 24. We're ready to take our straight edge and connect the lines, connect the dots. Draw a line through our 2 intercepts. Make sure it's nice and straight, arrows on each end. We've got the line, now we're ready to decide which side we shade. So let's check 0, 0. That'll be 0.5 times 0 plus 0.8 times 0 greater than or equal to 20. Anything times 0 is 0, anything times 0 is 0. I get 0 greater than or equal to 20. Is this true or false? This is false. So if 0, 0 is false, any ordered pair on this side is false. We shade the other side. In terms of the real world part of the answer, recall that we cannot have negative muffins. So this piece really is not going to actually be part of the real world answer. Our real world answer is limited to the portion of the shaded region that fits into the first quadrant. And then across. So for example, this mentally think that this would keep going in the shaded region below here would not be something that I highlight because I can't have negative scones. Just this is part of my real world solution. 2 possible answers. Once again, if you're just allowed to pick anything, I would clearly go with choosing something obviously in the middle. Like anything up here would be safe. So for example, I'll just randomly pick this point right here. That's 16. So this is 20, comma 32, which means if she sells 20 muffins is on the x-axis, 20 muffins and 32 scones, she'll sell at least $20. What if there was a question that required testing a point? For example, a question could say, if she sold 8 muffins, she needs to sell at least how many scones? So I'd come to 8 on the x-axis and I'd look up, looks like 20, but that would be 8 comma 20 with a question mark because this is on the edge. So let's test it. Let's pretend like we were asked a question, if she sold 8 muffins, she has to sell at least how many scones? I think 20, but let's see if we can check the point and be sure. So that'll be 0.5 times 8 plus 0.8 times 20, and we're hoping to see if this is greater than or equal to 20. So 0.5 times 8 would be 4, plus 0.8 times 20 is 16. Is that greater than or equal to 20? Well, 4 plus 16 is 20. Interesting. Is 20 greater than or equal to 20? Yes, it is. Because we have the or equal to part built into here, the answer would be 20 scones. It puts her right at her goal. So 8 muffins and 20 scones would get her at least the $20. If this came short, like if this was 18 instead of 20, 18 is not greater than or equal to 20. So you'd have to go back, even though this looked like it was a solution, it would just be outside of it if it came out to be a false statement. The last question is about puppy dogs. So this one, start to finish, it would be great if you can work on this one on your own. So I'm going to pause it. The first part I'm going to do is underlining the question, defining the variables, writing the inequality, and finding the intercepts. So when you press play again, all of that information is going to come up. So press pause here if you didn't try this one yet. Do those things. Underline the question, define the variables, write the inequality, find your intercepts, and we'll compare answers. Just in case you weren't sure how to start, because I noticed here the question is actually not part of the initial description. It's actually right here, write an inequality and graph it. I did press play real quick just to make sure we're on the same page with where the question actually was, what our variables are. I let X be the number of bags of expensive food, Y is the number of bags of cheap food. Here's my inequality, $6 per bag of expensive plus $2 per bag of cheap food, and he wants to spend no more than 48. Okay, so now I'm going to pause it and do the intercepts. So if you needed help getting started, I just helped you get started. Now get your intercepts. Press pause now. This is what I got for my intercepts. X-intercept, I got X equals 8. Y-intercept, I got Y equals 24. And now I'm ready to graph. Y equals 24 is going to be way up here on the Y-axis. X equals 8. Oh, sweet, I can fit it all on one screen. That's great. X equals 8 is right here. I'm actually going to slide it down just a little bit more so I can fit some labels here. I'm not given a label, so go look. How did you define X? What does X actually represent? X, for me, was the number of bags of expensive food. And Y was the number of bags of cheaper food. This is where a straight edge really comes in handy, guys. Please make sure you're not just trying to sketch the line. The straighter the line, the better we'll be able to actually use our graph to make some decisions here. For this one, I don't actually have any other quadrant other than the first quadrant. So let's see what happens when we check 0, 0. My train of thought jumped ahead a little bit. Sorry, guys. Let's check 0, 0. Check 0, 0. So that will be 6 times 0 plus 2 times 0 less than or equal to 48. Again, when we go back to the check, we're back with an inequality here, not an equal sign like we had over here. So I get 0 less than or equal to 48. That is true. So I know I will shade the side that 0, 0 is on. Coming back to my thought, I'm going to shade the side that 0, 0 is on, but I don't have any graph outside of the first quadrant. So I'm just going to very carefully make sure that I stay inside this triangle. Don't want to shade anything outside of it. How many pounds of the cheap dog food can he buy if he wants at least 1 pound of expensive dog food? So this is the information I know. 1 pound of expensive dog food. Well, this is where variables, defining your variables and labeling helps. Expensive dog food is a value for X. So what we're saying is when X is 1, what's the possible Y value? Well, I go to 1 on my x-axis and I trace this all the way up. I think 21. I'm thinking 21, but it's going to get a question mark because it's on the edge. So to really know if this is okay, we have to check it. So let's check this point. This is going to be X. This is going to be my Y value. So that becomes 6 times 1 plus 2 times 21. And I need to see, are we going to stay inside the budget of $48? 6 times 1 is 6. 2 times 21 is 42, less than or equal to 48. Ooh, look at that. 48 less than or equal to 48. That is okay because expending exactly 48 works for him. It's in his budget. But notice how close we came, right? A single dollar more. If this was 49 instead of 48, he would not be able to buy the 21 pounds. So the answer is 21 pounds of cheap dog food. If he decides to buy 4 bags of the expensive dog food, what is the greatest number of inexpensive bags he could buy? So now I know 4 bags of the expensive food, still a value for X. So I go to my x-axis and I go to 4 and I go up and I look. I'm thinking 12. I think we need to check it though because I'm not sure. My line was shifted just a little bit more in one or the other direction. That could or could not be possible. So I'm going to put 1 comma 12 with a question times the charm. 6 times 4 plus 2 times 12. Is that less than or equal to 48? 24 plus 42 less than or equal to 48. That becomes 60. What am I saying? 66 less than or equal to 48. That's a no, because 66 is not less than or equal to 48. So that's where we kind of come back to the drawing board and say, well, what if you just bought 11? Let's knock it down by 1. So 6 times 4 plus 2. Wait a second. Oh, I'm messing this up. So based on this question, I know I am going to check 4, 12. I'm going to put a question mark because we're not sure. So that will look like 6 times 4 plus 2 times 12. Is that less than or equal to 48? Let's see. 6 times 4 is 24. 2 times 12 is 24. Less than or equal to 48. 48 less than or equal to 48. That checks. We're just okay, literally, because they are exact. So if he decided to buy 4 bags of expensive dog food, the greatest number of inexpensive dog food bags he could buy is 12 bags. That's it. Nice job, folks. Please send any questions my way on Remind, and I hope you all have a good day, and I'll see you tomorrow. Study, 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 study.